Okay. What we are going to cover on chapter 9 is what is called hypothesis testing. Okay, what is hypothesis testing? Well, hypothesis testing is nothing but testing hypotheses. Hypotheses about what? Okay. Usually we test hypotheses about the value of the population parameters. In this chapter we are going to cover parameters mu and p. Mu is the population mean and p is the population proportion. And we are going to base our conclusion on the sample. And from the sample, we're going to get the statistics, X bar and P bar, that is the mean of the sample and the proportion of the sample. That's it. I mean, really, that is that simple about what is hypothesis testing. And in this chapter, we are going to cover the hypothesis about the population parameter based on a particular constant or value. For example, we are going to have that mu is equal to 80 and against that mu is not equal to 80, or that the p is less or equal than 0.3 against that the population proportion is greater than 0.3. Okay? So, as you can see, in every hypothesis testing, we have two hypotheses. Two hypotheses. One that is called the null hypothesis, or H0, and the other one that is completely opposite to the null hypothesis is what is called the alternative hypothesis. Okay, and it's H sub A or H sub 0 in some textbooks. Okay, now we have two hypotheses, the null and alternative hypothesis, and the null sets some hypothesis and the alternative is completely opposite to it. In hypothesis testing, we may have three types of hypotheses, and that's it. When the null hypothesis has an equal sign, then the alternative has a non-equal sign. When the null hypothesis has a less or equal, the alternative has a greater. And the third alternative is when the null has a greater or equal and the alternative is a less. As you can see, always, the null hypothesis has a equal sign, either equal, greater equal, or less than equal. So, we are testing hypotheses and we may have two conclusions. Okay. First of all, let me tell you something. What we are testing is the null hypothesis, but what we want to prove is the alternative hypothesis. Okay? So what we are testing is the null hypothesis, so our conclusion is either reject the null hypothesis, and it's funny because the other conclusion can be fail to reject what? The null hypothesis, because that's the hypothesis that we are testing. In statistics, we do not accept the null hypothesis, we just fail to reject. So, we really find statistical evidence in favor of the alternative hypothesis only when we reject the null hypothesis. Okay? So, we have two conclusions, rejects and fail to reject. Now, since we are basing our conclusion on a sample, and hopefully this sample has to be representative of the population, because if not, then our conclusions would be useless. Okay, now, since we are basing our conclusions based on a sample, we can make mistakes, of course. Okay, let's say the conclusion, and this is the real world. And this is the conclusion. In the conclusion, we have the reject, the null hypothesis, or we may have the fail to reject the null hypothesis, right? That's the only alternative that we may have in our conclusion. In the real life, we may have that the null hypothesis is true or that is false. The null hypothesis is false. Okay? So, what happened here? When we fail to reject a true null hypothesis, we are doing a pretty good job. When we reject a false null hypothesis, we are doing a pretty good job, right? But what happens when we reject a true null hypothesis? We are having one type of error. This is an error, and this is called type 1 error. And the value is alpha. And when we fail to reject a false null hypothesis, we are committing the type 2 error, and is beta. Okay, we as statistician have control over alpha, but we do not have control over beta directly. The only control that we have over beta is, and alpha and beta goes hand in hand, but in opposite direction. If I increase alpha, I decrease beta, and vice versa. Also, another way to decrease beta is increasing sample size and be sure that all the standard deviation of all the populations are equal. But anyways, okay. Anyways, alpha is the one that we control. We have control over alpha, and alpha is nothing but the complement of the confidence level. Okay. The most important part in hypothesis testing is hypothesis formulation. Now, remember, we testing the null hypothesis, but what we really want to prove is the alternative hypothesis. Why? Because the only way that we can have evidence in favor of the alternative hypothesis is by rejecting the null hypothesis. Okay, so the formulation is a key element in hypothesis testing. When we have a research question, the research question goes in the alternative hypothesis because that's the one that we would like to prove. Now, when we have a claim from someone like, my light bulbs last more than 3,000 hours, what we would like to prove is the opposite of that claim. So the opposite of the claim goes in the alternative hypothesis, so the claim itself goes in the null hypothesis. So let's say my light bulbs last at least 3,000 hours. So it's a claim, so it goes in the null hypothesis. We say the mu is at least 3,000 hours is greater or equal than 3,000 against the alternative that is less than 3,000. So what we want to prove is that the claim is false. So this is the way that the formulation of the hypothesis should take place. Okay. Now, in this chapter, we are going to have hypothesis about the population mean or the population parameter. And we have two situations in the population mean, is whether or not we know the standard deviation of the population. And this is very similar to confidence interval, but in the fact that when we do know the standard deviation of the population, we're going to use the standard normal distribution. When we do not know, we're going to use the t-distribution, and in the proportion, we are going to use the standard normal distribution.